Okay, in this lecture we're going to talk about rational equations again. And the difference will be, instead of leading to a linear equation to solve, these will lead to quadratic equations that we'll have to apply our quadratic techniques to solve. Alright, so these are leading to quadratic equations. So let's look at an example. Alright, let's suppose we want to solve each equation. Alright, part A. Right, let's suppose I have x take 5 over x take 3 plus 1 on x is equal to negative 7 over x squared take 3x. Right, so once again we look for things we can't have. Of course we can't have x as 3 as a solution, and we can't have x as equal to 0, so that can't be a solution. Secondly, we see that x squared minus 3x is equal to x by x minus 3. Right, so if we look for a common denominator, clearly it'll be x by x take 3. So when we do this term here, we'll need to multiply the top and the bottom by x so that I have an x take 3. Plus here we're going to have to multiply the top and the bottom by x take 3 to get the common denominator. And over here we're going to have negative 7 by x take 3. Now notice we have a common denominator here, so therefore we're going to have, so this implies that x by x take 5 plus 1 by this, which will be of course just x take 3, must be equal to negative 7. Right, so if I now distribute, we get x squared minus 5x plus x minus 3 equals negative 7, which means we're looking to solve x squared minus 4x, and bring this across. We add 7 to both sides. I'll get plus 4 equals 0. So I'm looking to solve this, and of course to solve this we're looking for factors of 4 which add up to negative 4, and of course that'll be x take 2 by x take 2, which implies of course that x take 2 equals 0, which implies that x must be equal to 2. Now 2 is not on our list of things we can't have, so 2 looks good, and we should check to be sure, and we should have is 2 take 5 over 2 take 3 plus 1 on 2 equal to negative 7 on 2 squared minus 3 times 2. And yes, you'll see that it is, and so our solution, alright, is 2. Okay, right, part B, let's suppose we want to look at x over x plus 5 plus 5 over x take 5 is equal to 50 over x squared minus 25. Okay, number one, notice here that we can't have x equal to negative 5, or this would be 0 here. We can't have x equal to 5, or this would be 0 here. And second, we also notice that x squared minus 25 is equal to x by x take 5. So our common denominator here will be, of course, x, oops, that's not x, sorry, it's going to be x plus 5 by x take 5. So let me write that again. It's the difference of two squares, x squared minus 5 squared, which of course is x take 5 by x plus 5. Alright, so notice here that the common denominator then will be x take 5 by x plus 5. So I'm going to need an x take 5 here on the top because I have an x take 5 that I need to multiply on the bottom, plus 5, and I'm going to need an x plus 5 here over an x take 5 by x plus 5, and that's going to be equal to 50 over x take 5 by x plus 5. Now notice that all the denominators are the same, so the numerators must be the same. So x by x take 5 plus 5 by x plus 5 must be equal to 50. which implies, of course, that x squared minus 5x plus 5x plus 25 must be equal to 50. All right, well, notice here, what do we have? So these cancel, so what I have is x squared plus 25 must be equal to 50, which implies that x squared must be equal to 50 minus 25, which is 25. Using our square root property, this means that x must be equal to negative 5 or x must be equal to 5. Now notice that both of these are on my list. All right. Both x equals negative 5 and x equals 5 cannot be solutions. And there's no other choices, so there is no solution. And so we either use empty brackets like this, or we use this symbol here. Okay, and that's how we do solving rational equations that will lead to the solving of a quadratic equation to get the solution.